Hi, AB Calculus class. We're working on 2011 question number 5. It's a separate and integrate question. It's one of the topics that'll be on your quiz and more than likely one of the topics on your AP exam. Alright, so the problem is a separate and integrate question. You'll get to part C and it'll be worth 5 of the 9 points. Okay? Doesn't mean it's an easy question. It's a really weird question because you're not used to seeing separate and integrate with things other than x's and y's. Now, whenever I see this, I like to think of this. I think, all right, normally things are dy dx, but this time it's dw dt. The reason this is important is this helps me remember that the w is like the y and the t is like the x. So you can't go and change them, okay? But it will help you think why things maybe make some more sense. Okay, so let's go ahead and start with part A. It says, use the tangent line at t equals 0 to approximate the solid waste that the landfill contains at the end of the first 3 months. Okay, well, what two things do you need for a tangent line? You need a point, and we need the point when time is 0. And you might be thinking, okay, that's only one of the coordinates. Now remember, time, t is kind of like x. So that's 0, but what is w? And while that seems insanely weird, like what is w to begin with? You have to go back to the very first sentence. In the very first sentence it says, in the beginning of 2010, there were 1,400 tons of waste. And in the problem, we are saying that t is measured from the start of 2010. So this is, t is 0, so this is the waste at the beginning. So that's my point. Now remember, this is working like the x and the y, but instead of an x and a y, it's a t and a w, and that's a slope. That's a point, sorry. Now we need the slope. The slope comes from the derivative. Well, we have the derivative, dw dt, and dw dt, we want to know specifically what is the slope at this point, 0, 1,400. Now, here's the big problem I ran into in the past. First time I did this question, I did this. Wrong. I saw time was 0 and threw a 0 in here, but 0 is time. We're not putting time in here, we're putting w. There's actually no place to put the time. There's only a place for the w. So we actually are putting 1,400 into the problem. And this is the slope. Now, if you want to simplify it, you can. Okay? I don't want to. But if I did simplify it, you could subtract those. And then you could end up getting 1,100 over 25. And you could even divide and get 44. But instead of 44, that's kind of hard to simplify, like without a calculator and not wanting to make a mistake. You could do it, but why not leave that for the slope? I know it's not pretty. You could use this for the slope or 44, but if you don't do the work, 44 is a little tricky. No calculator on this, for this question here. Although in the AP exam, they're going to let you use a calculator if you want one. All right, so let's go ahead and write my point and slope as a tangent line. So instead of y minus y1, we don't have y's. Remember, y's are like w's. So it's w minus w1 equals m, the slope. Now my slope I can say is 44, or I'm going to pretend like I didn't simplify it, I didn't have time. So I'm going to use that for my slope. I know it's ugly. Alright, so that's my slope. So, or that's 44. So y minus y1 equals m. All that is m, and then x minus x1. But remember, your x's are t's. So it's actually t minus t1, which is 0. Okay, so that's your first part. Write the equation of a tangent line. The second part is to use this to estimate the amount of solid waste in the landfill after the first 3 months. Or in other words, when time is 3. So all we're going to do here to finish this question is we're going to take this. And again, remember, this is just 44. We're going to put a 3 there. 3 minus 0 is simply 3. And then I got to add this to the other side. And there you go. Again, you could do 44 times 3, add 1,400. If you do that, it looks like the answer is 1,411. I want to make sure everything is good before I move on. Oh my word, you don't plug a 3 in there. Unreal. I hate math sometimes. Wow. I was thinking T is in months. Just going back here, it says T is measured in years. They hate us. So 3 months is 1/4 of a year. I should have read. T is in years, not months. So 1/4 actually goes here. So this T is not replaced with 3, it's replaced with 1/4. And then we're going to add that 1,400 to the other side. So if we work this out, 44 times a fourth is 11, plus 1,400. If you simplify that, you get this. Okay, wow, that's part A. All of that was part A. Wow. All right, let's go ahead and erase it and go to part B. Now, when I erase it, I'm going to keep some of it here. Okay, so part B says, hey, that answer we just got, that we had it this long, but you could have made it 1411 if you wanted to, is that an over or under estimate? It says, find the second derivative, and then use that to find out if we have an over or under estimate. Well, how are we going to find the second derivative? Well, the first thing I'm going to do, I don't want to take the derivative of this right now. I'm going to distribute the 1/25. So if I distribute the 1/25, I get 1/25w, and then when I multiply that times that, do an easier calculator, that's fine. Think 25, 4 of them goes into 100. 4 times 3 gets you to 300, so this is 12. Okay, now I want to take the derivative. But before I take the derivative, I want to show you something. Because you're about ready to make a mistake, potentially. Think about this. Remember how I said that basically the w and the t are like the y and the x? If you keep that in mind, you'll realize that this is implicit differentiation. Meaning, if I were to take the derivative here, I would say the derivative of 1/25y is just 1/25, but times the chain dy dx. And then the derivative of 12 goes away. You might not have noticed this. Your main variable is time. You're taking the derivative of w with respect to time. It's related. It's not related. Well, it's fine. Related rates. Or another way of thinking about it is implicit differentiation. So when I go to take the derivative here, I get 1/25, and the derivative of w is 1/25, but we get this little chain here. And then the derivative of 12 is 0. It's gone. All right. Now, we're going to now replace this because we know what this is. What is dw dt? It's all of that. So all of dw dt now replaces this. So now we get another 1/25 w minus 300, and we now have the second derivative. Now that we have the second derivative, they want to know, was our first answer an over or under estimate? Well, let's go back and look. What was the w we were using in the previous question? The w we were using when time was 0, the w was 1,400. So if we were to plug a 1,400 in here, you will see that's a positive. A positive times a positive times a positive is a positive. Our second derivative is greater than 0. Now, why does that make a difference? Well, if our second derivative is greater than 0, that means our graph is concave up. And if our graph is concave up, what does that mean? It means our tangent line is an underestimate. So because the second derivative is greater than 0, our estimate of f of, it wasn't f of 1 point, sorry, it was w of, our estimate from part A, fine, let's just do that. Part A was an, again, underestimate. Using ordered pairs on a tangent line gives you underestimates from the real answer. So it was an underestimate. I did a question right without a mistake so far. Wow. Okay, let's go erase this and go to part C. All right. C. It says, oh wow, it says the same thing. Find the particular solution. Go back and watch the first two videos. Find the particular solution. Find the particular solution. Find the particular solution. Finding the particular solution is the part of the problem that is separate and integrate. All right. So to do separate and integrate, first thing I have to do is get this dt to the other side. Okay? And the w's all have to go over here. Well, the only way to get the w's over here is to use division. What about this 1 over 25? He's got nowhere to go. He just stays put. And that's all we do for separating. This divides to the other side, this multiplies. The 1 over 25, you could multiply 25 to the other side, but the more you bring over, the more you got to bring back. You're better off just leaving it. So that's separating. And now we're going to integrate. On the left-hand side, this is a du over u, which is an ln of u. The reason it's a du over u is the bottom exponent is 1 bigger than the top. There's no exponents on the top. So if you were to go ahead and make sure everything was in the right spot, you would say if the u is w minus 300, the derivative, well, the derivative of w is simply 1 dw. And what do we have on top? 1 dw. So this is exactly du over u, so it's just ln of u. So it's ln of absolute value u. On the other side, let's just think really quickly. If somebody said, what's the antiderivative of 7? You say it was 7x. Right? If someone said, what's the antiderivative of 17? It's 17x. So here, the antiderivative of 1 over 25, because it's dt, it's 1 over 25t. Okay, so we separated, we integrated, we put a plus c. Now comes the all-important using this. When time is 0, w is 1400. If we do this on this side, we get c, because that's gone. And over here, we get ln of. Now tell me, with those absolute values, is that not horrible? It looks like 1, 1, 1, 0, 0, and even ln. ln, I don't even know. That looks just crazy. But here's the important thing. Does my absolute value have a job there? No. So I'm actually going to use parentheses just to help me make this look different. The absolute values didn't have a job. That'll be important later on. So we separate, integrate, solve for c, plug c back in. By the way, we are doing part c. So we get ln of w minus 300 equals 1 over 25 t plus ln of 1100. So we just take the c and we plug it in there. And now all we got to do is get w by itself. We could simplify a bunch of stuff when we do this problem, but we're not going to. No, no, no. We just want to get our points. Last point is just getting w by itself. So we ln both sides. Okay. And now the absolute value, we go back. Did my absolute value have a job here? No. Since it did not have a job, we can get rid of the absolute value. And then the only thing left to get w by itself is to add this 300 to the other side. And there you go. Is there a way to break this up into this and this? Yeah, technically you could have had the 1100 in front of the e to this. I just didn't choose to. You get w by itself, you win, you get all the points. So let's get our points and go away. All right, thank you. Bye.